Hello, in this video I will be talking about two things. First, I will be talking about long division of polynomials, and second, I will be talking about integrating improper fractions. Let's start with considering this fraction of polynomials. Now here I have a polynomial of degree 3 over a polynomial of degree 2. This is called an improper fraction when the degree of the numerator is greater or equal than the degree of the denominator. We call it a proper fraction. First of all, let's see how we perform a long division of polynomials. So I'm dividing x cubed plus 3x squared plus 6x minus 8 by x squared plus 2x minus 3. So what we do is that we put x cubed plus 3x squared plus 6x minus 8 here on the right, and x squared plus 2x minus 3 on the left. First of all, we divide the first term on the right, from the right, by the first term from the left-hand side. So we divide x cubed by x squared. So x cubed divided by x squared would give me x. Then what we do is that we multiply all of this by x. So we multiply x squared plus 2x minus 3 by x. So we will get x multiplied by x squared, x cubed, x multiplied by 2x, 2x squared, and x multiplied by minus 3 minus 3x. Then I'm sorry, let me get these out of the way. Then we subtract x cubed plus 2x minus 3x plus 2x squared, minus 3x. We subtract it from x cubed plus 3x squared plus 6x minus 8. So x cubed minus x cubed is 0. 3x squared minus 2x squared, it's x squared. 6x minus 3x, so plus 3x, it's 9x, and minus 8 minus 0, because I do not have a constant here, so it's minus 8. Then again, I take the first term from the right, I divide it by the first term from the left, so x squared divided by x squared, it's a plus 1, so I get plus 1 here. I multiply x squared plus 2x minus 3 by a plus 1. I multiply here, so it's the times, I multiply, I would get x squared plus 2x minus 3. Again, I subtracted from x squared plus 9x minus 8. I will get x squared minus x squared, it's 0. 9x minus 2x, it's 7x. And minus 8 minus 3, so plus 3, it's minus 5. Now, the degree here, it's 1. The degree here is 2. It's strictly less. So we stop our division, and this would be the remainder. And this is how we perform a long division of polynomials. When we finish this long division, we will be able to write x cubed plus 3x squared plus 6x minus 8 as x squared plus 2x minus 3 factor of x plus 1 plus the remainder, so plus 7x minus 5. And since we are dividing x cubed plus 3x squared plus 3x minus 8 by x squared plus 2x minus 3, so now if we divided, we will, if we divide it by x squared plus 2x minus 3, we will get from the first part here, we will get x plus 2 because we are going to simplify by x squared plus 2x minus 3. And here we will get 7x minus 5 over x squared plus 2x minus 3. Now, in the second part of this video, I will be performing the integral of this improper fraction. If you're not interested in seeing how I integrate this improper fraction, you can stop watching if you want. But if you like this video, do not forget to hit the like button and to subscribe. Now, let's see how we integrate this improper fraction, which is the one that I already divided, or I already performed the long division. So this is an improper fraction. The degree of the numerator is greater or equal, but here it's strictly greater than the degree of the denominator. So the integral of this improper fraction would be equal to the integral of x plus 1 plus the integral of 7x minus 5 over x squared plus 2x minus 3. So I have now an integral of a polynomial, which is very simple to integrate, and another integral of a fraction of polynomials, but now it is a proper fraction because the degree of the numerator is 1, which is strictly less than the degree of the denominator, which is 2. So integrating a proper fraction, I'm going to go a bit quickly here. If you want them in details, you can see other videos that I've done when integrating a proper fraction. I'm going to go a bit quickly here. I need to find the degree, the roots of the denominator, which are going to be, the roots of the denominator are going to be 1 and minus 3, because here it's a second degree polynomial. A plus b plus c is equal to 0. So the roots are 1 and minus 3. So we can write the denominator as x minus 1 factor of x plus 3. So this proper fraction can be decomposed into two partial fractions, which are a over x minus 1 plus b over x plus 3. Now a and b, I can find them by cover up, using the cover up method. To find a, we cover x minus 1 in the left hand side here, and we replace in what remains x by 1, because 1 is the number that makes x minus 1 0. So I'm going to get 7 minus 5 over 1 plus 3. So 7 minus 5, it's 2. 2 over 4, so it's half. A is half. To find b, we cover x plus 3, and we replace in what remains x by minus 3. So we get here minus 26 over minus 4, which is 13 over 2. So b is 13 over 2. More details about the cover up method in another video that you can watch if you like. So I decompose this partial fraction into this, proper fraction into two partial fractions. And so j would be integral of half over x minus 1 dx plus integral of 13 over 2 over x plus 3. Putting these constants outside the integrals, I would get half integral of 1 over x minus 1, which is of the form u prime over u, and we'll get ln u. And also here, 13 over 2 integral of 1 over x plus 3. Also, it's the form u prime over u, because the derivative of x plus 3 is 1, which is ln absolute value of x plus 3. So j would be half ln absolute value of x minus 1 plus 13 over 2 ln absolute value of x plus 3. And finally, don't forget that we are integrating I, the improper fraction, which was integral of the polynomial x plus 1 dx plus j that we have found here. So finally, we will get that I is half x squared, which is the integral of x, plus x, which is the integral of 1, plus j, which we already found here as half ln absolute value of x minus 1 plus 13 over 2 ln absolute value of x plus 3 plus a constant c, since we are solving an indefinite integral. Thank you very much for watching.